From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
The hardware over the last few years has seemed to outstrip the capabilities of the software, right? So, we've just seen at Formnext 2020 this week that SLM are bringing out a machine with 12 lasers in it, right? And a 600 by 600 by 600 build volume. Additive Industries are talking about a concept where they're going to build a metal fab 600, again, a 600 by 600 by 1 meter multi-laser machine. We've got Velo doing similar. People are going bigger and bigger, and they're fitting out their machines with either more lasers if you're in that metals world, or they're fitting their machines out with more heads if you're in that sort of inkjet 3D print world. And with that increase in size, with that desire to move into mass production, what you're seeing is your build preparation and data complexity ballooning. The data requirements are ballooning. The time it takes to slice files across these much bigger volumes is exponentially rising. The ability to generate ever more complex proprietary toolpaths, getting more and more complex, taking more and more time. And we've got, as I say, very, very performant, capable hardware, but the software that traditionally has generated those build files and has generated those toolpaths, or even is used to simulate the build process, that's getting slower and slower and slower, because really those products that are on the market today that people tend to use have been built on legacy architectures.
That was Stephen Anderson. Stephen is the Vice President of Business Development at the Dyndrite Corporation. Dyndrite has built the world's first GPU-powered hybrid AM kernel capable of reading native CAD. Previous to his role at Dyndrite, Stephen was the additive manufacturing business development manager at Renishaw, leading the 3D printing metal business for the company in the US. He joins the show today to talk about the evolution of software in the 3D printing space and the growing need to have evolved solutions keep pace with the increasing printing speed, capacity, and throughput of 3D printing machinery. So, Stephen, I met you when you were at Renishaw, but for those in our audience who may not be familiar with some of the work you've done and kind of the current work that you're doing, do you want to just give us a brief intro on kind of where you got your start in additive manufacturing?
For sure. Hi, Mike, and thanks ever so much for having me on your show. Yeah, for those people who don't know me, my name's Stephen Anderson, and I'm now the VP of Business Development at Dyndrite Corporation. But I met you before that when I was the head of business development for Renishaw, working out in Chicago from 2017 to 2020, where I was leading the AM effort there with respect to their powder bed fusion machines. I was at Renishaw for quite a long time. I've been in engineering for about 20 years. At Renishaw in a variety of roles, both technical and commercial. I'm a chartered engineer, and for a number of years I was the head of group software at Renishaw, and I led a team of about 250 odd software engineers, both in India and the United Kingdom, and we were responsible for building software across Renishaw's product range, ranging from CMM software, machine tool probing software, encoder product software, and also into the healthcare sector, and more recently additive manufacturing, which is where I really got to know powder bed fusion technology quite well, but also the whole process of print from the digital workflow from CAD to print. And I was part of and led the project teams that, first of all, re-engineered and rewrote machine control software for the powder bed fusion machines of Renishaw, but then also got into writing build preparation software a product called Quantum, and then from that, other software, which was factory management of their AM powder bed fusion machines, a product called Infinium Central, and then more recently we built, sorry, a software product called Infinium Spectral, which was for visualization and analysis of photodiode data, in situ process monitoring data, collecting build data off the machine as a print was occurring. So I learned quite a lot about additive manufacturing, and particularly on the metals side, as I say, over a number of years. And then from 2017, moved into a commercial role, moved over to Chicago and drove the AM business for Renishaw there. That's when we met, first of all.
Yes, that's right. And now you've kind of transitioned to a new role. Do you want to tell the audience a little bit about there, and then we'll kind of dig into that?
I'm going to use that dread word COVID, right? So, I'd actually met the folks at Renishaw previous I think I first met them at one of the AMUG shows back in 2018, even somewhere as far back as that. And I got to know the CEO and founder there, a chap called Harshal Goel, really quite well. And we'd sat on a couple of occasions, him, Sean Hopwood, the CMO, and myself, and we talked about the Dyndrite vision for software in additive manufacturing. And as a software guy, I sort of got it without being too big-headed. I saw what they were trying to do, and I thought it was really interesting. But in all honesty, I was quite comfortable at Renishaw. I thought that I would be with Renishaw for a few more years. But my secondment came to an end in 2020. And of course, I was returning back to the UK in the middle of COVID, which was a very, very interesting time to come back to the UK from the States, flying on one of the last planes out of Chicago kind of thing, with face masks on and not having a house to come back to and not having a car and all that kind of good stuff. And ultimately, not being able to continue my career at Renishaw. And so I found myself, talking to a bunch of folks about various opportunities, and indeed, started up the conversation again with Harshal about, whether there were opportunities to work with Dyndrite. And, thankfully there were. In fairly short order, really, but I think it was all done and dusted within a few weeks, which is testament to, the speed at which Dyndrite work. I'd transitioned that from Renishaw to Dyndrite. I think I'd left Renishaw on a Thursday kind of thing and started with Dyndrite the following Monday. Started with them in June. So I'm coming up, the end of this year will be sort of the 6 months in at Dyndrite, and it's just been a fantastic ride and a wild ride, and I'm loving every minute of it.
And so, taking a step back, as you've seen kind of the evolution of software within the 3D printing space, what are some of the big takeaways of in your opinion, kind of where the technology is from a software perspective, as you think about most of the users you may have interacted at Renishaw, or as in kind of this new role, people that you talk to, what are you seeing on the ground as kind of the status quo?
So I guess there's sort of two stories that I'd like to talk about there, right? And the first one, I think, is the sort of experience I learned, previously. So as I said at the start of the interview, we stood up a project to write build preparation software for the Renishaw machines, and we decided to do that internally at Renishaw, partly because of the sort of culture of the company. Renishaw is a company that invests a lot of money into research and development. Indeed, its strapline is apply innovation, and we were inventing new techniques, new hardware techniques, new algorithms in the powder bed fusion machines that we wanted to exploit and support in software. And we didn't really want to do that by having to communicate that IP, that know-how, that expertise to a third party. So, of course, the logical consequence, and we were in a fortunate position to have a reasonable size software group that I ran at Renishaw, we were in a position to stand up our own project team and to build out our own software tool. But the experience of that is, while you can build that software, even at a company the size of Renishaw, it wasn't really or it shouldn't really be the core focus of a machine builder to build the software, right? It's not that what their key skill set is, if you like. And of course, it's an expensive thing to have to do. And so you find over time that you've actually got more and more software resource dedicated, to looking after a piece of internal or even saleable software, which isn't really where you want to be. And there was part of me that was thinking, well, there's got to be a better way of doing this, right? And then on top of that, the second sort of story that I tell is that you're within the world of additive manufacturing. Metal additive manufacturing is where my history has been, but I think this is also true across all additive manufacturing, from sort of professional machines and up, as it were. Is that really the hardware over the last few years has seemed to outstrip the capabilities of the software, right? So we've just seen at Formnext 2020 this week that SLM are bringing out a machine with 12 lasers in it, right? And a 600 by 600 by 600 build volume. Additive Industries are talking about a concept where they're going to build a Metal Fab 600, again, a 600 by 600 by 1 meter multi-laser machine. We've got Velo doing similar. People are going bigger and bigger, and they're fitting out their machines with either more lasers if you're in that metals world, or they're fitting their machines out with more heads if you're in that sort of inkjet 3D print world. And with that increase in size, with that desire to move into mass production, what you're seeing is your build preparation and data complexity ballooning. The data requirements are ballooning. The time it takes to slice files across these much bigger volumes is exponentially rising. The ability to generate ever more complex proprietary toolpaths, getting more and more complex, taking more and more time. And we've got, as I said, very, very performant, capable hardware, but the software that traditionally has generated those build files and has generated those toolpaths, or even is used to simulate the build process, that's getting slower and slower and slower, because really those products that are on the market today that people tend to use have been built on legacy architectures, which are 30 years old, and really we need a whole new way of thinking. And that new way of thinking is I'm pleased to suggest, is the Dyndrite way of thinking, right? Which is, we will use the power of afforded by GPU technology to be able to process these ever more complex data sets really, really quickly. And more importantly, we will then provide that power, that capability as a kernel engine that we will supply to machine OEMs or to independent software vendors, or even to large-scale enterprise end users, so that they can consume that kernel and write their proprietary plugins and their proprietary software codes for their own toolpaths, or for their own physics codes, for example, or even for their own factory automation workflow, without having to tell us what they're doing with their machine, without having to give away that IP, without having to give away that know-how and expertise, right? And that's great, because I think that affords the best of all the worlds. You can stand up your software team now without having to employ a whole bunch of maths experts to do that computational kernel, because we can provide it. But equally, you can hold on to your IP because we don't want to know it. We are providing the kernel, the engine, sometimes I call it the glue that holds the ecosystem together. And it's an efficient way for OEMs, ISVs, and some of those large end users to actually get to where they need to be for mass production without having to invest significant resources in their own software teams.
How do you think about well, in my experience, you may have kind of opinions on this as well, with kind of organizations that are setting up AM facilities, centers of excellence, whatever you call them, production facilities, and they're going to kind of high-end equipment, whether it's metals or 12 system lasers. When they think about the stand-up of these facilities and the operation, I've mostly seen or observed that kind of the crown jewel is the physical hardware, right? You can show VIPs, you can kind of bring tours through, and like that's the crowning achievement, and that's where a lot of the funding goes to, for the end user to put effort into getting that machine in, and less effort shown on understanding the process, certainly at the front end, like you were discussing, of, okay, what's it take to design and implement and even put a build file together into your system to make it efficient and make the vision of production a reality. Do you think companies or organizations or people standing up these facilities are getting smarter about that, or is there still kind of some learnings to take away?
I think companies are getting smarter about that, and I think it's quite interesting that the idea of the center of excellence that you were talking about there. It's almost as if in the past few years, large organizations have been dipping their toes in the water with respect to this technology, and they say, okay, we'll build up this center of excellence, to learn the technology, to learn. Let's use metals again, right? Because that's the area that I'm most familiar with. So let's get the technology in. Obviously, we have to think about health and safety because we're dealing with metal powders and lasers. So we need to learn all of those processes, which means we build out this facility in a certain kind of way. And that's great. We learn about all of that, right? Then we've got all of that materials knowledge that we have to, acquire or reacquire, because we're used to milling metal. Now we're actually, fusing metal powder together. We need to understand the durability, the wearability of those kinds of materials, okay, and do all the fatigue testing, and get all the tensile samples and all the coupons and all that kind of stuff, and perform all the metallurgical tests that we need to ensure that the material is good, right? So there's been a lot of attention in that kind of area, and as you say, it's great to bring the execs through this shiny facility, right, where you've got these quite expensive machines. We all know that some of these machines are very, very expensive to buy. And you can show that you are this shining beacon of expertise and know-how in the workplace. But I think 30 years on, right? There's a lot of companies now are saying, well, that's all very well, but we've got to take these technologies into production, right? For quite a long time now, they've been in prototyping. We've had small production runs in aerospace, for example, which have got fairly long lead times. But of course, we've never seen these technologies, or rarely seen these technologies on the metal side, get into real volume. Okay, we've seen some notional, very small runs for high-performance sports cars, for example. But the idea that you're making tens of thousands or hundreds of thousands of metal components for automotive, for example, hasn't yet materialized. And as I say, part of that is the throughput of the machine, but the machines, as I've said, are getting bigger and faster and better. So where are the blockers? Part of the blockers are in the software, right? As I said before, part of the blockers are, just general build preparation, the amount of time it takes for your applications engineers to lay out the build, to understand how they're going to orient parts with respect to gas flow and wiper direction. And there is an attendant cost in that. And then, of course, you do all your experimentation with your parts, and then your design folks come along and change the design on you. So you've got to do it all again. And the software process is quite slow at the moment. It doesn't adapt easily for you to be able to make those changes quickly. And then on top of that, if you're in a factory environment and you're actually trying to produce, as you will know, Mike, and some of your software attends to this, is it's all very well to print a part or to mill a part, but that part is then going to go through a whole set of operations after the event, right? So post-machining operations, it's got to be clamped, it's got to be machined, it's got to be labeled, it's got to be packaged, it's got to be, anodized, whatever the process might be. And your AM machine in your factory, your AM machines need to fit into exactly the same ecosystem that your CNC machines fit into. So they need to be integrated into MES systems or your ERP system, or even at the front end, your PLM and your CAD system. And that side of it, I think, has been severely lacking. It's starting to get some attention now, but part of the advantage of Dyndrite is not only does it have the power of the GPU kernel, which allows you to generate these files very quickly and to place labels very quickly, but also you have the power to record in Python the script, the layout script, if you like, the build preparation script of the job that you are printing. And because you've got a Python code, you can then interact and integrate that code into things like MES, ERP, QDB, and so on. And I think that is incredibly powerful, and it is a mechanism and a tool which further helps take these machines into that mass production context, because for the first time you're actually able to pull your serial numbers straight from your ERP system, apply the labels according to some logic that you've originated in your manufacturing process. You can codify your AM production rules in Python and then execute them, and you can execute them automatically. You can execute them headlessly. You can double click the script and off it will go. It will generate the build file. It will accommodate a change. It will apply labels. It will generate a report or whatever you need it to do. And it will do that at the speed that you need, afforded by the GPU kernel underneath.
For sure. And I imagine kind of sitting in your new role, one of the really exciting things about the software part of additive manufacturing is that this doesn't apply just to a particular type of technology, whether it's metals or polymers, that you get to interact with all levels of the ecosystem, the end users, the machine manufacturers, even to some extent, probably material suppliers. And over the last few months, you've done some pretty cool events, including kind of Dyndrite Day, which was, I think, last week or the week before. Do you want to talk a little bit about how kind of the marketing approach and interacting with the industry has kind of shaped some of the direction of the company?
Yeah, sure. I think again, we've got quite an interesting approach with respect to our marketing, right? So we don't like to directly market ourselves. We like to market ourselves through our customer successes, right? So, we like to get, if we can, other people talking about how they've used our technology or how they're intending to use our technology, why they're looking at our technology, what are their challenges, and how does our technology address those challenges. So when we organize our events like Dyndrite Day, very often we have guest speakers, keynote speakers who are experts in the field and who've had longevity in the field, who have really got something quite important to say about how AM has progressed from basic 3D printing and prototyping all the way through. As I say, these days there are companies printing millions of components on their own machines, right? And so when we do these events, and Dyndrite Day was the last one, we were fantastically lucky to have Greg Morris as our keynote speaker. a lot of your listeners will remember that Greg, started off with Morris Technologies, and really was one of the pioneers in terms of metal printing. That led into GE's acquisition of Morris, and then we all know how successful GE has been in the aerospace sector with respect to metals printing. So Greg gave a keynote, talking about his new venture, Vertex Manufacturing, and what they're doing in the space, and how he sees how the Dyndrite technology can be applied to that mass production use case. We were very fortunate to have Anthony Graves from HP, who leads their effort with respect to the HP Universal Build Manager, which is a really exciting opportunity where HP are bringing a new build preparation software package to market, which is powered by Dyndrite's kernel. And the great thing about the Universal Build Manager is in its name. It is designed to connect with every single printer under the sun, so that as a user, an end user of AM products, right, you might have polymer printers, metal printers in your factory. You can now standardize potentially on one build preparation package, so you don't have to train lots of your techs and operators in lots of different packages. You can standardize on one, and they will integrate with all of the different machine OEMs who want to work with them. So Anthony, gave a great introduction to the HP Universal Build Manager, and then the other key piece of news at Dyndrite Day was Dyndrite itself, announcing that as well as the kernel, we've got tool pathing APIs now that the OEMs can use to build out their proprietary tool pathing mechanisms on our kernel to get the benefit of the speed of that. And we also announced a whole new set of operation, a whole new set of voxel-based operations and APIs, so that we can act on data and turn that into voxel representations, which in turn can be sliced into pixel representations and create image outputs for sort of the raster-based processes that other printers need. So it was a fantastic event, and if people missed it, they can type the various search terms in YouTube and find it, or indeed I think they can get the link to it from our website as well, and they can hear those keynotes talking about the future of AM and mass production, and they can also see some interesting Python scripting demos from our head of product, Steve Walton, as well.
From an end user perspective, as people are thinking through kind of buying their next printer or kind of updating some of their current processes, how do you recommend, or how do they engage with Dyndrite so they see some of the new capabilities? Are there kind of machine kind of demos or demos of kind of the software that you have now to show some of these value add approaches?
So they in terms of sort of evaluating which next printer to buy, I think that's a very, very interesting question, right? So there are there's lots of choice out there. We've talked in this interview about bigger machines, okay, speeds and feeds of machines, if you like. In terms of how those machine OEMs interact with Dyndrite, again, a quick visit to our website. You'll be able to see a bunch of the companies who are on our Dyndrite Developer Council. The Developer Council is a really interesting concept. So basically, we're building a core technology that we want OEMs to use. So frankly, we need our OEMs to tell us what it is they want to see in that core technology, right? So twice a year, we get together with all of our Developer Council members, and it's their chance to feed back to us and tell us, what areas of functionality we should be concentrating on, which ones are important to their customers, the ultimate end users. And as I say, if you go to that website, you'll see a whole bunch of companies on there. The likes on the powder bed side, there's the likes of Renishaw and SLM and Trumpf and EOS and Additive Industries. We've got a bunch of the polymer companies on there as well. There's the software folks that we're talking to, the likes of Altair, Ansys, a whole raft of companies that we're working with. So that should give people who are interested in buying new technology an indication of the sorts of companies who are actively engaged with us. I think that's probably the answer. To go take a look at our website, and if that doesn't give you the information that you need, by all means contact myself, and I'd be delighted to talk to you and find a way to get demos into your hands, or provide examples of Python scripts or whatever.
Right. And one of the other events that I guess the first iteration of this one, I think it was the first this summer, was there was a kind of investor day that you invited all sorts of emerging companies in the AM space to have a day to kind of pitch investors along the lines of kind of advanced manufacturing and AM in particular. And we were talking just before we went live that the next version of that's happening in January, right?
Yeah, again, hugely exciting. It's one of the things that I love about working with Dyndrite is the way that that the management thinks about this space and how this space needs to develop, and how as a community we can it's all very well to compete with each other, right? But there's got to be a greater good, and the greater good is to push the whole agenda for additive manufacturing along, so that it does become regarded as just another CNC, right? Another mainstream manufacturing process that can produce parts at scale, because ultimately that feeds into our business philosophy. And as part and parcel of that, of course, we're working with the folks on our developer council. They're the big companies of today. But of course, who knows who the big companies of tomorrow are going to be? There's some fantastic ideas out there for new businesses in additive manufacturing, for new types of technology, for new software companies who are adding to the piece. And part of that smart thinking, if you like, is to encourage these new startups to come together with venture capital companies to talk about what it is they're trying to achieve, and Dyndrite tries to support that activity to foster those conversations. So the next Digital Manufacturing Investors Day is actually going to be on the 19th of January. But if you're a startup and you're looking for funding, you can apply right now. Go to our website. You can apply right now to be one of the, if you like, pitch companies. There'll be a whole bunch of investors there listening to the companies that are going to be pitching. I think the closing date for that is something like the 6th of December. So you've got to get your skates on. There's only a few weeks now before the close date, but it's a great opportunity to meet with a bunch of like-minded people, present your pitch, get feedback, and also get your message across. And we're proud to sponsor events like that, and to host events like that with our other sponsors as well.
Fantastic. Well, I definitely encourage anyone that's listening to check that out in any future events. So, Stephen, before we go, is there anything else our listeners should keep an eye on for, or that you'd be pointing them to in addition to the website, or any other collaborations that we should highlight for the day?
I think just a quick final one would be just to mention that the HP Universal Build Manager again. I might have said this already, but I will say it one more time. If you're interested in what HP are doing, powered by Dyndrite, go and have a look on their website. You can sign up now, I think, to be an early tester, to get early evaluation licenses of the Universal Build Manager. I think 2021 is going to be an incredibly exciting year as that technology comes to market. I think combined with events like the Investor Day, and always keep looking at our website, because we release new functionality on a fairly regular cadence. So there's always, or usually, something new to look at with Dyndrite every month or so. I think 2021 is going to be very, very exciting. I hear on the news that we're almost there with the vaccine, so hopefully we'll all be in a position to start meeting up again. Events like this webinar have been fantastic for 2020, and I thank you once again, Mike, for hosting me. But let's face it, we all want to start meeting up with each other again, right? And going to shows and all that kind of stuff. So that would be awesome. I wish everyone a great, I know it's very early, but I'm not quite sure when this is going out, but I wish everyone a good holiday season. And 2021 is going to be a roller coaster, and I'm really looking forward to it.
For sure. And hopefully we'll get you back here in Chicago for AMUG or Rapid.
That would be awesome. I'm looking forward to it, although I'm not missing the Chicago winters.
So for sure. Well, it's 30 degrees right now, but it's at least sunny. So. All right.
Excellent.
Well, thank you so much for joining the show, and we'll talk to you soon.
Excellent. Thank you very much indeed.